Okay, so we find our coefficients 1, 4, 6, 4, 1. Okay, 1, 4, 6, 4, 1. Once you know your coefficients, like I said, you start with the highest one first in your first one. So that'll be a to the power of 4. And you're going to keep decreasing this by 1 while you increase the other one up by 1. So plus, decrease it by 1, increase it by 1, but there's meant to be a coefficient of 4. Plus 6a, decrease it, increase it. Decrease it, increase it, decrease it, increase it. Can you see what's happening? 4, 3, 2, 1, 0, 0, 1, 2, 3, 4. And then, of course, all your powers always add up to 4. So 3 plus 1 is 4, 2 plus 2 is 4, 1 plus 3 is 4. And then there's your coefficients, 1, 4, 6, 4, 1. Anyone have any questions? No, that was easy done. Cool. So I'm assuming these will be okay. Can I leave these ones for? Maybe we should just do this one. All right, good, let's do this. So 5, choose 0. 5, choose 1. Go. 5, choose 0 should be 1. 5, choose 1 should be 5. 5, choose 2 should be 10. Then it should be 10 again, and then 5, and then 1. All right, so 1, 5, 10, 10, 5, 1. All right. First one, 1 to the power, and then your coefficient is 1, so that's just going to be 1. Plus 5, that's 1 to the power of 5 technically. 1 to the power of 4, but then negative 1 root x to the power of 1. Plus 10, and then again 5, 4, this would have been power of 3, so then this one's going to be power of 2. Do you guys get that? Because technically there's a 1 cubed there, but I'm not going to write it. Too much. 1 squared, and then negative 1 root x power of 3, plus 5, negative 1 root x power of 4, plus negative 1 root x to the power of 5. And then all you can do with this question is just make it look a little bit better. But that's it, you're done. Squared becomes 10 on x. See what I mean by your algebra is going to be really good after this? All right, any questions? No? Okay. Okay. So the binomial theorem simplified is sigma, which means sum of. So sum of n choose k, so you either write nk as a bracket or n choose k. You'll probably see me writing more n choose k's. only because I have a tendency of writing a fraction there, because I teach the younger grades as well, and we do fractions still. So I get mixed up sometimes, and so to avoid that, I just use n choose k. But that's the same notation. Sum of n choose k, xk, starting from 0 all the way up to n. Sum of. Which we know is true, because what would you do usually, right? Didn't I tell you go to n choose 0 to get your first one? Then it's going to be that one to the power of n, and then this one to the power of 0. Then you'll do n choose 1, you decrease the other one and increase this one up by 1, and just keep going, increase by 1, increase by 1, increase by 1. So n choose 1, n choose 2, x squared, n choose 3, x cubed. Very important formula, or very important expansion. We're going to be doing that literally for the next 2 weeks. That expansion. 1 plus x to the n needs to expand like this. All right, as always, let's have a look at a question. So you're going to get questions like this in your exam. It's going to say, find the coefficient of x cubed in this. Now, of course, you could expand it, right? Which I will for a second. But then I'm going to show you the professional way of doing it. So first we're going to expand, then I'm going to show you the actual way you need to learn it. So if I had to expand this x minus 2 to the power of 5, I know it's going to work like this, right? 1, 5, 10, 10, 5, 1. Those are my coefficients. Then it's going to be x power of 5 plus 5x power of 4 negative 2 plus 10x cubed negative 2 squared plus 10x squared negative 2 cubed plus 5x negative 2 to the power of 4 plus negative 2 to the power of 5. This becomes x power of 5 minus 10x power of 4, 40x cubed, negative 80x squared. What's that? 16 times 5, 90, plus 90 x, and then minus 32. Who feels confident they can get the first line out? Obviously a bit slower, but who feels confident in being able to get the first line out by decreasing and increasing?
Sort of.
Sort of.
Yep.
Anyone actually confused and not sure at what's happening altogether, or can't see the patterns that I'm trying to say? Okay, and then if you had to, what's the coefficient of x cubed? Coefficient is 40. Okay, but like I said, you've got to learn it the professional way. The professional way is this: at any point of my expansion, right? Can you guys see how it's going to be n choose 0, n choose 1, n choose 2, etc.? I can actually make a formula to take a snapshot if I just want to find this component here. The way that works is at any point, my formula would be n choose k, a to the n minus k, b to the k, where a and b are just a plus b to the n. So at any point, I'm technically always doing this. N choose k, I'm finding at a certain point, and then the first one to the power of this take away whatever we chose, and then b to the power of whatever we chose. So let me show you how this works here. So in other words, you would have n 5, and we're going to use this formula a lot. 5 choose k, and the idea is you're trying to find k. X to the power of 5 minus k, 5 minus k, and then b, negative 2 to the k. Again, anyone not see what just happened there? Seriously, anyone? Nope. Okay. The good thing about this is at any point, well, where do you want it? You want it at x cubed. We want x cubed. We want x cubed. So that means this component here needs to equal to x cubed, because then this and this will be the coefficient. So what should k equal to? What would k equal to?
2.
2. And then look at the answer. You'll get 5 choose 2, negative 2 to the power of 2. I guarantee you this gives you 40. Because your coefficient of x cubed when k equals to 2, which is 5 take away 2, is 40. So that is that's like pretty much, I could say 50% of your binomial questions using this formula and understanding how this formula works. So hopefully I'm going to make it easy, but you guys got to really see that and how that's working, and let's do some more. Any questions before I move on? Okay, let's see. Okay, so like this question here, find the coefficient of x to the power of 5 in x minus 1 and x plus 1 to the power of 7 multiplied together. Okay, the formula was nck, all right, before I continue it, an minus k bk. Now, let's talk about something with expansions, because I think a lot of students just initially miss the whole point of the expansion. Think about an expansion like this. How do I get x's coefficient of x? What's the expansion here to get a coefficient of x? It would be this multiplied by this and this multiplied by this. So same thing with this. If you're thinking of coefficient of x5, it would be x multiplied by, what would happen here? x4, right? Because x times x4 gives you x5. And then what about this one? 1 times what is going to give you x5? So if you think of that logic, again, we're gonna start. So x plus 1 to the power of 7 equals 7 choose k, x to the power of 7 minus k, and then 1 to the power of k, which doesn't do nothing. And then x minus 1, you might as well leave it as it is. So just leave it as x minus 1. There's no point of, because that's linear. So why do you want to complicate it and write like 1 choose k? Like that's just, that's silly. So just leave it as it is for now, equals x minus 1. Now think of the expansion of these two. What could happen? Well, it could have been x multiplied by this, so 7 choose k, x 7 minus k multiplied by x minus 1 multiplied by 7 choose k, x to the power of 7 minus k. Because this is at any point, And then obviously you're multiplying, so this multiplied by this. Do we get what I've just done there by multiplying? What I've done is now, like, my bases are the same, so I'm going to add the powers. So 7 plus 1 is 8, minus 7, choose k, x 7 minus k. So for this component, what does k need to equal to for you to get coefficient of x5? For this component, what does k need to equal to? And then that would be your answer. 7 choose 3, take away 7 choose 2, which I'm guessing is 14. See how we found the coefficient of x5? All right, let's go back up again. This is weird, right? You guys gotta admit that. It is a weird topic. It's weird because it's some serious algebra that's required. You gotta understand what yeah.
Sam,
Sorry?
is it alright if you say it once more? Because it's kind of like tripping me out.
Yes. I think the thing that what you need more than repeating this specific one is to keep going. We got to keep doing more and more of these, which we will.
Yeah.
But I did say 3 weeks, and I don't think you guys hear me say that. I don't know if I've ever said that for many topics. So this one takes about 3 weeks to say that yes, I get it. But again, think of think of the example I've given you above. If I said, hey, go find the coefficient of x. What's the coefficient of x? You would have said that's 1x minus 3x. So the coefficient of x would be negative 2. Right?
Yeah.
That's the exact same logic, but the problem is this second one is not the power of 1. So I can't just expand it like this. It's the power of 7. So what I'm going to do is create this as a little formula and go, okay, I can find that at any value of x. It's fine now. I've created a simple formula for it. So then x, just like this was, x multiplied by this minus 1 multiplied by this would get me stuff. Can we say that? Will get me like different kind of x's depending on what I want. Do you agree with that?
Yeah.
Just expanding will get me different types of x's depending on the expansion of what you're expanding, obviously.
Yeah.
So what happened was this simplifies to x to the power of 8 take away k because of your index laws. This stays the same because there's nothing to simplify. You didn't multiply it by x, you multiply it by negative 1. Then what you've got to ask yourself is, when will this be x5?
So you put S2 and you put the other one as 3.
When will this be x5? Yeah.
Okay.
When will it be 4? When will it be 3? When will it be 2? When will it be 1? And you can find it at any point now. You just go 7, choose 1. That's the whole idea.
Okay,
right.
I get it, yeah.
It is. But it is what you said. It's a bit trippy. It is. This is that kind of topic. Which I'm actually glad they brought it into year 11 because it does require the time. And a lot of teachers actually just skip this because they can't. It's really hard. And a lot of students would usually walk into the HSC going, binomial theorem, I'm going to get 0. So
yeah. Thanks, Sam.
let's go. We'll do it again. We're not going to do expanding because I think expanding is fine. Right? Can we agree with that? Expanding, you guys should get down pat. It shouldn't be a problem. It's more these ones. Find the coefficient of x cubed. Okay, Novak, you might as well do the first one with me. So the formula was n, do you remember it by any chance, or you've obviously written it down?
And that symbol?
Choose k.
And choose K.
Yep.
Wait. I'm so lost. That's not the formula that I have. What about that one when it was like n and the sum and then k equals 0?
Yeah, that's just how to expand it. But we want a snapshot of it at any point. Hold on. So this one here, this is the full expansion. Is that the one you're talking
Okay.
about? Yeah. At k equals 0. That's the full expansion. Now we only want it at a specific point. Like I only want this one. So to find that specific one, the formula is n choose k, a, n minus k, b, k.
And choose k.
A to the power of n minus k, b to the k.
Okay, got it.
That's technically what you're doing. See, if k was 2, a, 1 to the power of n take away 2 is still 1, and then it'll be x to the power of 2, k, x squared. See how you end up with this? So
Yeah.
this formula is what you've been doing. It's just a stronger formula because it works at any point.
Yep.
Where were we? Yeah. N choose k, a
N minus
minus
k,
k, and
bk.
then b to the power of k. That's for any expansion of a plus b to the power of k. Like anything, any two terms. Doesn't matter what this is. Doesn't matter if it's a fraction. It's always the same thing.
Okay.
All right. So let's see. Equals for this case. 4
Choose
k, and then bracket
3 plus
3 to the power of
4
minus k, and then
2x to the power of 4.
wrong. K.
Okay.
N
Yeah.
is 4. N is 4.
Okay.
N is 4. Sorry. Oh, that's because I wrote that K. N is 4.
Got it.
Got it? Okay. Now, let's fix this up to make it look a little bit nicer so we can only see the X's. Otherwise, right at this point in time, you've got a 2 in front of it. So next line, this becomes like this. This becomes like this. This becomes like this. Correct?
Yes.
Then, obviously, what should K equal to?
Cubed.
3, yeah.
3,
K
yeah.
equals to 3 since you want x cubed. So your coefficient is literally 4 choose 3, 3 to the power of 4 take away 3, 2 to the power of 3. Which gives you whatever that answer is, 2 to the power of 5, 32 times 3, 96. You don't have to leave it like that. I know Hubert just likes to leave things simplified. 96 is perfect. Easy?
Easy.
Okay, let's do it again. Find x squared term, not coefficient. Coefficient's the number in front of that letter, that pronumeral.
Yep.
The term is the number as well as the term.
So the whole thing, okay.
Yeah, that's all. All right, let's go. So nothing changes, pretty much, is what I'm trying to say. You want to try it one more time, Novak?
Yeah, sure.
So 12.
12 choose k, a, so that's 2, 12 minus k, and then it's minus x to the power of 12. K to the power of k.
If you did 12, you'll know you're straight away wrong because you just found x power of 12. The whole point is to find x squared.
X squared, yeah.
Okay, there's only one little trick here that students don't know, and it's how to factorize this negative out because you can't have it there. So it looks something like this. 12 choose k, 2 to the power of 12 minus k, and then of course a negative 1's attached to the k, a negative 1 is attached to the k, and then x to the k. Just like we did up here. We
Yeah.
split up our 2 to the k, x to the k, because you can only have x's. You only want single x's. You can't have two different x's. You can't have anything. So like even up here, we go up for a sec. Look here. When I multiplied it by x, I simplified it.
Yep.
Single x. Otherwise, you're not going to get your k out right.
Okay.
So go down. This negative needs to be -1 to the power of k, and then x to the k. We agree with that?
Yeah.
And then of course,
K equals 2.
so therefore you get 12, choose 2, 2 to the power of 10, and then -1 to the power of 2 is just 1, and then x squared. And that's the answer. 12, choose 2, 2 to the power of 10, x squared.
Aha, okay. It gets easier, yeah.
I make it easy.
Yeah.
This is hard. I'm cutting a lot of the crap out for you guys. But I know what's going to happen. Again, you guys are going to go to school, you're going to learn, and be like, oh, it's hard again. You can't. You got to look back at this and go, okay, yeah, it's fine. It actually is fine. Now we'll do more. We'll do more. All right, x squared. Let's do this one. How are we going for time? Yeah, good.
3.
All right. Who wants to give this a shot? Other than Novak. Come on, let's try it together. Who wants to do it? I'll pick Shania. Shania, let's do this together.
Right, okay.
You ready?
Yep.
The formula is n choose k, a, n minus k, b, k. All right, n is equal to 6, so we're going to write 6, choose k, and then?
X 6 minus k.
X squared, 6 minus k, yep, and then?
1 over x to the power of k.
That's it. Now, you can see there's a whole lot of x's, and I just said it has to be a singular x. So my next line, I'm going to expand this. That's going to become 12 minus 2k. This, I don't like it in the denominator, so I'm going to change it to x to the power of. So think of index laws, 1 on x.
Minus 1 k.
Yeah, -1, and then if you know it's -1 multiplied by k, can I just do that? Saves me a step. Is that okay?
Yeah.
Done. And then bases are the same. What are we going to do to the powers? So we're multiplying bases that are the same. What do you do to the indices?
Add them.
Add them. 12. Take away 3k. And you're done, right? You found it now at any point. It's saying find the term independent of x. That means you're trying to find x to the power of
0.
0. Yeah, the constant term, the one that doesn't have the x, pretty much. So in other words, when k equals to?
0.
No, oh, no, you're going to solve. When k equals to 4. Do you get that?
Yes.
So then this becomes 0, which is then your answer is just 6 choose?
4.
4. Make sense?
Yes.
That's meant to be the hardest style of question for the singular bracket that you can get, because what they've got the two x's, and then the second x is an index law kind of question. So that's the hardest question you can get for singular brackets.
Okay.
Cool. Easy. Well done. Anyone have any questions? All right, Lucas, let's do the next one then. So you're going to say everything. I'm not going to try to say much now.
7ck.
7ck.
2x to the -2.
2x -2. Fair enough. Yep. To the power of
7 minus k.
Mm-hmm.
Times x to the 5k.
Oh, yep. You can already see what's happening. That's even better. And then we're going to simplify this thing. So it's going to be 7ck, and then
2 to the 7 minus k.
ooh, very
X
nice.
to the-
Split up your numbers and your letters. So 2 to the power of this, and then x.
X to the negative 14 plus 2k.
Yeah, too good.
And then
Well,
you've got the x to the 5k.
and then personally, just so you guys know, if I was ever doing this in my math work, I wouldn't really write x5k again. I know I'm going to add this. You guys got to start to learn. As much as you're working on accuracy, you are also working on speed. So there's no point of me writing this and wasting a whole nother line again, right? We know we're about to go 2k plus 5k. Well, I'm just going to come back here and I would have just changed that to a 7. That's it. So Lucas, I want you to do the same thing.
Okay.
Accuracy is there. You got to get your speed up. So then, and then of course you want the constant term.
K is equal to 2 when you solve.
Yeah. K equals to 2, and then just sub it in. Very good. All right, what do we reckon? You getting better? Good stuff. All right. Let's try this one again. Without fully expanding, find a term containing. Yeah, without fully expanding. We're not going to expand. Okay. Let me see if I can find. Oh, that's the one. But maybe not yet. All right, let's do this one first. Find the term containing. So, like I said, these are the hardest ones for singular brackets. For our binomial expansion, so like for double brackets like this, there is again a way of doing it. So let's do it again. Let's try it again. All right, 3 minus x power of 4. We get our formula for this. 4 choose k, a to the power of 4 minus k, b to the power of k. Now what you've got to see is that is multiplied by 1 plus x. So technically this whole thing is multiplied by 1 plus x. So Novak, tell me, if this is multiplied by 1 plus x, what are the things I get? When you expand this with the right hand side. So sorry, this with this. This is one term, right? Just so you don't know that. So think of it as like 5. 5 times 1 plus x. What would your answer have been?
So 5.
So this is just one. Yeah. So this is one big 5. There's no pluses. So it's just a number. Yeah, go. Tell me. What would you get?
Oh, so would it be 4 choose? Wouldn't it be the whole thing times 1?
Yes.
And then plus the whole thing times x.
Yes. There we go. You see it now. It's just this whole thing is a massive 5. So 5 times 1 plus 4 choose k, 3 to the power of 4 minus k, negative x to the power of k times x. Good. We see it now. All right, I'm just going to get a black color. All right. So again, fix this up because you don't want to have a negative. It's not going to work very well. So 4 choose k, 3, 4 minus k, negative 1, k, x, k, plus 4 choose k, 3, 4 minus k,
minus 1.
Negative, yep, minus 1, k, xk times x would be
x2. X plus 2, yeah.
No.
That's 1.
K plus 1, man. Careful, that's a term, that's a variable. K plus 1. All right, you pretty much did it. You did the hardest step, and then obviously now it's easy. What do you want? You want x cubed.
K equals 3.
For this one, and this one is k equals to 2.
Yeah.
And that's it. Whereas I think your teachers, when they're going to do this, just so you guys know, they're going to use 2 different letters, which is okay as well. But just so you know, maybe they might use two different letters. They might use K and R. Sometimes I do as well, but I didn't want to overcomplicate it. So that's why I've done this. But you got to understand when you're doing K here, it's only for this component, and when you're doing K here, it's for this component. All right, the answer is 4, choose 3, 3, 1, -1. The power of 3 is negative, plus 4, choose 2, 3, 4 take away 2 is 2, -1 squared is 1, and that's it. And then that should give me, from the top of my head, 42. 42, and then obviously these are x cubes, if you wanted the term, compared to the coefficient. Confirm, Novak, it's right, it worked out to give you 42. And then we'll move on. Okay, did it work? No, that was waiting on you. You'd probably have to write it times if it's saying syntax or something. So 4 choose 3 times 3 times plus 4 choose 2 times 3 squared.
Yeah, well.
Works? Alright, done. Thank you, Andy. Alright, let's do this one. So this would be the hardest one you'll get for the binomial, so the two bracket cases, where the powers are not, where both brackets are not powers of 1, so they're not monic. Whereas this one here, at least one bracket was power of 1, so it didn't make it too complicated. These ones are the hardest ones, so let's try it out. Nothing should change. So 7, but nothing should change, but we can't use k's for both. So this one here would be the one. You can't really use k for both because by the time you're going to expand it, a lot of things will be incorrect. So we're going to do 7, choose, because as you guys can see, like k's can be two different values. So it's going to look like this. 7, choose k. X to the power of 7 minus k, and then x to the power of -1 times by k. That will be multiplied by 3, choose r. X to the power of 3 minus r, and then minus x -1 to the power of r. You can pick any letter, doesn't really matter. Okay. I think that's fairly straightforward. Now what you've got to think about again is the expansion of all this. All right, but wait, let's fix up some stuff firstly. Oh, no, we don't need to fix it up, right? The reason why I'm not going to fix it up because this is all multiplied. So everything here is just multiplied. So what am I going to do to all my indices? Just going to add them. Can you guys see it? Maybe I'll do it slower. Hold on. 7, choose k. X 7 minus k, x -k, times 3, choose r, x 3 minus r. That's -1 to the power of r, and then x to the power of -r. And then can you guys see that? Yeah, like I said, it's all multiplied. So I get 7ck with 3cr, -1r, so 7ck, 3cr, -1r, with x to the power of 7, take away k, plus 3 minus r, take away r. 7 plus 3 is 10. Take away 2k, take away 2r. All right. Novak, do you get what I've done up to this stage?
Yeah, I do.
Now we need x squared. We need x squared. Again, Novak, I'm going to pick on you for a second. X squared. If you were thinking of the expansion of this multiplied by the expansion of this, how would you get x squared? Can you tell me? How would you have got x squared? Like what component here multiplied by what component here would have got giving you x squared?
Wait, sorry, what?
What component in here multiplied by what component in here would have given you x to the power of 2? I'll give you an example of one. X times by x can get me x squared.
Yeah.
And then what's another one?
X squared and 1.
Yeah, right, x squared and a constant.
Constant, yes.
And then a constant here multiplied by?
X squared.
Okay. Something along those lines, right?
Yeah.
There might be more as well, so there could be, maybe x times x is x squared, but, this is power of 7, so maybe, there'll be more x's and x's, let's say, by the time these simplify as well within each other. But you got the general idea. So that's technically that's the idea of how you're going to expand to get x squared. So what I'm trying to say is when you know that idea or the logic behind it, we've got this problem here that we can't just solve for k like we've been doing before. But what we know is the cases for such a thing to occur. We understand the cases for when they are to occur. So 10 minus 2k minus 2r needs to equal to 2. Right?
Yes.
So then I'm going to divide everything by 2 as well. Why not? Just to simplify my math. 5 minus k minus r equals to 1. Or in other words, I might bring this over and bring this over. So I get 4 equals to k plus r. So as long as k and r is always 4, I will always get my coefficients of
X squared.
x squared. And just so you guys can all see, that's all the math that's been simplified. So this works. As long as 4 equals k plus r, I will get my x squares. So without expanding, that's the only way you're going to get those cases that we just spoke about up here. All right, let me get rid of that. I think we get what's about to happen now. Now we've got to run through our cases. So, Novak, you're going to say when r equals r. When r equals 0, k equals?
4.
Of course, when r equals, come on.
I am
1.
when r equals 1, okay, k equals
K would equal to 3. R equals to 2.
K equals
K would
to
equal to 2. R equals to 3. Think about
1.
R. Don't forget what R is. R is this guy here.
Yeah.
Right? So R is equal to 3. K is equal to 1. Can you get R is equal to 4?
No.
No, because you can't do 3 choose 4.
Yeah, it's not possible, yeah.
It's not possible. You only have a power of 3. Anyways, you can't go power of 4. So, you're done. Those are all your 4 cases. Now it's just a matter of you subbing it in. So
Do you have to sub it for each individual case, yeah?
Yeah, so set like this. 7 choose K. 3 choose R. -1 to the power of 0. Plus, because you're adding your coefficients, right? If this plus this plus this. 7 choose K. 3 choose 1, negative 1 to the power of 1, plus 7 choose 2, 3 choose 2, negative 1, 2, plus 7 choose 3, no, 7 choose 1,
7 choose
1,
1.
3 choose 3, negative 1, cubed, and you are done. This would be worth 3 marks in both your prelims and your HSC.
Oof, what a mission.
Yes. If you compare these 3 marks to maybe, I don't know, 3 marks of like curve sketching, you would say that's a lot easier.
Yeah.
Well, that's why I said with this topic, it's not really a component of like you're trying to get 3 marks. It's more that if you do get these 3 marks, you're probably going to come first in the class.
Yeah, true.
So that's what these 3 marks are. These 3 marks are not really to just get like 80% or 90%. These 3 marks are, I'm going to come first. So, all right. But the majority of it was the same. I hope you guys can see that. I mean, I introduced R. Sure, there was a little bit more algebra required, but the component, I still made it equal to 2. You know, I still made it, and then all you had to realize is there are different cases of that occurring. When R is 0, then K would equal to 4. Just like when he's saying here, when this is a power of 2, this is going to be an x power of 0. When this is an x power of 0, this is going to be a power of 2. When this is a 1, this is going to be a 1. That's pretty much what you're solving. And these are the cases of when they will occur. All right. I'll give you guys a second to write that. Okay. Okay. I can start factorials, but why? You guys are just starting to get this, so you know what I'm going to do. And I'll pause that. I'm sure I've already got all the answers from the other class. I'll send you that. What we'll do is we'll get a binomial. Yeah, let's just start with the first one. All right. I want you guys to just try it. Try that one. Find the coefficient of x cubed in the expansion of 3x plus 4 to the power of 5. Try basic one for a second. Excuse me. All right. Let's see if you guys got it out. Up to the first stage. 5 choose K. 3 x to the power of 5 minus K. B to the power of K. And then 5 choose K. 3, 5 minus K. 5 minus K. 4K. And then you want x cubed. So therefore K would need to equal to 2, and then the answer is just 5 choose 2, 3, 5 take away 2, 5 take away 2, yep, it's 3, and then 4 to the power of 2. Are we happy with that? Yes? Anyone not able to get that out? Okay. Emily, you get what's going on? Shania, all good as well? Just want to make sure.
Yeah, it just takes me a while to do it.
Yeah, oh, well, it's the first time, right? So it's okay. I think the only thing I can say with that again is just you got to repeat it. Like me, if let's just say our class finishes in a few minutes, I'll spend the next 5 minutes just repeating, writing this out 4 or 5 times until my hand gets faster writing it out. Because it is new. The way to write it is new. So that's what I will be doing. And then you'll be surprised. You'll get pretty fast with it fairly quickly. Because it is really repetitive in that sense. Okay, then what if I now say to you guys, I'm going to give the exact same question, so at least we know what we're going to do with our first line. Right? Get rid of all of this. And we'll say, okay, let's multiply this guy by 2x minus, 1 on x to the power of 5 as well. And we want to find all the x cubed cases. So the first thing we know we've got to do is find our formulas for each individual case. So we've got that, and now we need it for this guy, which is going to be 5, choose r, 2x to the power of 5 minus r, and then negative 1, or negative x to the power of negative 1 to the power of r. Then, as always, we break it up just so we can see what our components are for our x's. That's just that, multiplied by 5cr, 2 to the 2x, sorry, no, it was right. 2 to the power of 5 minus r, x to the power of 5 minus r, negative 1 to the r, and then x to the power of negative r. And then, any questions at this stage? Emily, again, do you get what I've just done there right now?
Yeah, I think.
Yeah, so write that, put that to the power of this, x to the power of, wait, what happened to that? Wait, did I do something? I did something wrong, didn't I? Should have been x to the power of 5 take away k, and then 4 to the k. 5cr, 2 to the power of 5 take away r, there it is. X to the power of 5 take away r, there it is. Negative 1 to the power of r, there it is. And then x to the power of negative r. At this stage, we get 5ck, 3, 5 minus k, 4k, 5cr, 2, 5 minus r, negative 1 to the power of r. That's your coefficient. Just so you guys understand, that's our coefficient of x to the power of 5, take away r, plus, because again, it's all just multiplied, plus 5 minus r, plus negative r. So you add your indices. Five plus 5 is 10. 10 take away k, take away 2r. Equals x cubed. And of course, because I made this question up, it doesn't work very nicely, but who cares? 7 equals k plus 2r. All right, Novak, let's get you back in. Give us our cases. Just keep in mind the maximum value that r can be and the maximum value that k can be. So, what are you going to start with? R equals?
0.
R equals 0, I think so too. K equals to 7, but can it be 7?
Sorry, no, it can't be 7.
No, so that won't work. But that's what I would have tried as well, so don't worry. Then you'll realize that doesn't work.
So
R
we'll
equals-
start from 2.
R equals 1. Don't do
1.
that. R equals 1.
The
K
K,
equals
5.
5. So that does work. R equals 2.
Okay. R equals 2, so K would equal 4.
K equals 2. 2 times 2 is 4.
3. 3,
Take away
3,
4.
3, 3.
Yeah, 3. R equals to 3. 2 times 3
K would
is
equal
6.
to 1.
K is equal to 1. And I don't think you're going to get R is equal to 4 because that's going to give you 8. And that gives you a negative number, which doesn't work.
Okay.
That's it. 3 cases. And then you just sub it in.
And plus all of them, yeah?
And then plus all of them.
Okay.
That's like silly hard. I try to make it as annoying as I could. Just to show you guys, like it's kind of the same style. You still got to do your cases. Just keep in mind what we said at the beginning, your maximum value of K and R. So be careful there. And then really your answer is like this. 5C, 5, 3, 5 take away 5, 0. 4 to the power of 5, 5CR, 2 to the power of 5 take away 1 is 4. And then negative 1 to the power of 1 is negative 1 still. Plus, then you do it again. 5C, K is 3. 3 to the power of 5 take away 3. I think we all get how to substitute. 3, 5C, 2, 2 to the power of 3, negative 1 to the power of 2. Plus, and then last one, 5C, 1. 3 to the power of 4, 4 to the power of 1, 5C, 3, 2 to the power of 4, 3, 2, negative 1 to the power of 3. Wow, done. You can just leave it at that. If you want to simplify, you can simplify it. Whatever. All right. This one, well, this one's probably worth more like a 4 marker all of a sudden, actually. It's not really 3 marks. Probably actually more worth 4 marks. I just realized, because you're going to get 1 mark for your expansion of your first one, 1 mark for the expansion of the second one, 1 mark for probably getting to this line right here, and knowing to have simplified it, and then 1 mark for the final answer. So looking at 4 marks, more than anything. All right, I'll leave that one there.